Hello everyone, I am Alnur Hridoy and today I am going to talk about a dynamic programming problem known as the levenshtein distance or edit distance. What is levenshtein distance or edit distance? The levenshtein distance is a way of quantifying how different two strings are from one another by counting the minimum number of operations required to transform one string into another. The levenshtein distance between two words is the minimum number of single character edits required to change one word to another word. The levenshtein distance is measure of similarity between two strings. It is defined as the minimum number of changes required to convert string A into string B. The smaller levenshtein distance, the more similar the string are. This is very common problem of in the application of dynamic programming. Why will we follow the dynamic programming approach? Dynamic programming solves this problem by ensuring that each identical step is performed only once. By storing the result of the step in a collector, such as a hash table or an array, to be called each time is again needed. It follows a top-down approach, so we can say that the problem should be able to divide into smaller overlapping subproblems. An optimum solution can be achieved by using an optimum solution of smaller subproblems, and dynamic algorithm uses memoization. The edit distance problem has optimal substructure. That means the problem can be broken down into smaller simple subproblems, which can be broken down into yet some simpler subproblems and so on, until the solution becomes the trivial. There are three cases where transform string by performing edit operation on string X to subproblem of transform substring by performing edit operation on substring X. Case 1, the last character of substring X and Y are the same. Case 2, where the last character or we reach the end of the either substring. And case 3, the last character of substring X and Y are different. While X and Y are different, there are two situations can occur while comparing two strings: match, where no operation are needed to perform, or mismatch. Then we can perform one of these three operations to edit the string. Like first one is insert, second one is delete, and third one is replace or substitution. Each of these operations has a unit cost. For example, the levenshtein distance between keyten and setin is 3. The minimal edit script that transforms the former into the latter is keyten, where is replaced by setin, and substitution for of S for K. Second one is C10, where is replaced by setin, substitution of I for E. And last one is setin, where's replaced by sitting and insertion of G at the end. Insert. Insert the last character of Y into X. The size of Y reduces by 1 and X remains the same. Where the accounts for X size is 1 to I and Y size is 1 to J minus 1. As we moved on the target substring but not the source substring. Here are the example of insert. Delete. Delete the last character of X. The size of the X reduces by 1 and Y remains the same. This accounts for X size is 1 to I minus 1 and Y size is 1 to J. As we moved on the source string but not in the target string. Here the example of delete operation. And lastly, the replace or substitution. Substitute the current character of X by the current character of Y, where the size of both X and Y reduces by 1. And this account is X size is 1 to I minus 1 and y size is 1 to j minus 1. As we move to the both source and me and target string, while using the case 2, there is some the find distance recursively algorithm is showing to the slide. The irrelevant maintained throughout the algorithm is that we can transform the initial segment using the minimum segment operation. At the end of the bottom right array element contains the answer. For example, let x be kitten and y be city. The levenshtein distance between x and y is 3, where the I number of row and I number of column in the table are shown below on the levenshtein distance for substituting x I2 to I minus 1 and y size is 0 to j minus 1. For another example, if string 1 is intention and string 2 is execution, then the minimum edit distance between string 1 and string 2 turns out to be 5 as shown below. All operations are performed on string 1. Here the dynamic programming approach of Levenshtein distance. Now let's see how we can optimize the time complexity of this dynamic programming algorithm. The partial recursion tree of call sequence for function find distance string 1, string 2, integer m and integer n would look like following that this operation. Here the dynamic programming table for Levenshtein distance. Each cell of mn of this array represents distance first m characters of string 1 and first n characters of string 2. For example, where m is 0, distance between string which of length is 0 and string of n length is n. Observe the zero row and above matrix, same in the case for values of zeroth column where string of the zero length. Now in this matrix for cell mn which represents distance between string 1 of length m character and string 2 of length n character. If mth character of string 1 and nth character of string 2 are same, then we simply need to fill cell using value of cell m-1 and n-1, which represents edit distance between the first m-1 character if string 1 and first n-1 character of string 2. Notice the red arrows in the above array are showing the dynamic programming table, which represents the distance between string 1 and string 2. Here the runtime analysis of Levenshtein's distance between two strings of length can be approximate to within a factor. That's the programming parameters turn to be in runtime order of n1 plus e. It has been shown that the Levenshtein distance of two strings of length n cannot be computed in time order of n2 minus e for any e greater than 0 unless the strong exponential time hypothesis is false. The time complexity of the above solution is order of mn and requires order of mn extra space, where m is the length of the first string and n is the length of the second string, which turns out the only two rows of the table are needed for the construction if one does not want to reconstruct the edit input string. Thank you.